Afternoon. I think kick things off. My name's Andy Wafaa. I work at ARM, and I'll be giving a lightning swirl through ARM's new architecture that's coming out, ARMv8. Also goes under the ARMv8 acronym. Some will be calling it ARM64, but that's a different whole kettle of fish. So, a brief history on ARMv8. It's about 6 years in the making. Should hopefully see real-world devices possibly at the end of this year, but we're hoping 2014. It's one of the most researched instruction set architectures that ARM's done. It's complete cross department work within ARM. So that was kernel tools, graphics. We spoke to everybody, trying to get them all to actually provide some input into it. It was prototyped in GCC and profiled on the emulator for both the ISA and ABI. And to try and expedite things, they parallel designed the prototype of the CPU and ISA in tandem to get the ball rolling. Instruction set architecture. There were several iterations of the process going through, and ARM also involved parts of their wider ecosystem in the design from the outset to try and minimize the existing landscape on ARM, which is huge. The intention was we wanted to try and minimize how much or how many different variants there were of the architecture out there. So one of the things that set out was what we want to get out of ARMv8. So targeting the high-end A-class family of processors. The A53 and A57 are the A-class processors that are first being released. A53 is the lower powered version, and A57 is the higher one. If you take it in existing CPU design, A53 is effectively the A7, and A57 is effectively the A15. Just so you understand the comparison there. Both physical and virtual memory addressable space being increased for both kernel and user space. One of the key factors is what's not going to be targeted. So high performance, in so much as we're not overly concerned about we need to break the 3 gigahertz barrier, we need to, outstrip the speed of light and processing, etc. That's not a focus. Also, static code size isn't a key target, but dynamic code size should be improved, especially with the inner loop instruction count. So one of the questions is, do we recycle the architecture from old, the V7, or do we start on a clean slate? You know, there's large flat virtual address space, implies 64-bit general registers. It's a new ABI that's going to be out there due to the data model and register size. We won't have any legacy artifacts within the new architecture. So old assembly code, old instructions, we don't want them. We want to avoid any bottleneck where possible, and we want to better use the resources that are going to become available. Also, with ARMv8 and the introduction of 64-bit, we don't want to forget 32-bit. There are still use cases for 32-bit going forward. So we'll be a great 64-bit, but we also need to be an excellent 32-bit architecture as well. And hopefully be continuing the rationalization of the instruction set that was started by the 32-bit thumb work. When recycling, you're going to get pain points. There are going to be some bottlenecks and other issues. So the original, or if you go back to the ARM7 CPU, about 1999, it had a 3-stage pipeline. An A15 of today has about a 15-stage pipeline. So it's orders of magnitude more complex. So that old pipeline doesn't work now, and it certainly won't work going forward. So, all register shifts on every arithmetic instruction, load store multiples. On a modern architecture, they can be much faster. Packing floating point and SIMD neon all help to avoid the potential pain points if we recycled. So going with a relatively fresh approach means we actually win considerably. It means that we'll have an architecture for the 21st century which will cover all modern operating systems, JITs, languages. It's more efficient. The encodings are cleaner and more useful. PC relative branch displacements for inline addressing can be carried. Unaligned addresses everywhere, almost. There are some corner cases. 32-bit or 64-bit index registers. Floating point improvements with Advanced MD and IE 754 2008. Load acquire and store release, as well as non-temporal load, store and prefetch. But we'll also be continuing the story of the new ARMv7. We'll be aiming for continued unified kernel, so single Z image across multiple platforms. Big Little will still be going forward, so you can have an A53 cluster with an A57. There are certainly use cases for mobile, but also potentially going forward in server and other devices. Virtualization will be supported with KVM and hopefully Zen. UEFI, which is effectively becoming the standard firmware across architectures, will also be supported. We'll be continuing with compiler improvements in both GCC and LLVM. Neon support with NE10. For those that aren't aware of NE10, it's a open source library that allows you to leverage Neon SIMD coprocessor, and also continuing making sure that Grub works out of the box cross-platform as well. So that's my brief overview of ARMv8. What I was kind of hoping as well is to get a discussion going on attitudes and thoughts on supporting the new architecture and how best to ensure that across the wider open source ecosystem, the new architecture can be supported if there's people that have views on how best things should be done. It'd be great to actually hear and try and get people from the different distros that are looking at supporting it moving forward. I know OpenSUSE have started their bootstrap of ARMv8. Fedora are certainly in the lead, and also Debian and Ubuntu are getting there. Be interesting to hear from distros like Gentoo, Arch, even the non-Linux side of things with the BSDs. If there's anybody here from BSD, chance? No? So it would be great to just see how people are planning on getting things rolling forward. Anybody got any comments to start off with? That you can actually get started with ARMv8 now by using the foundation model that ARM provides. Linaro have done a lot of work in bringing up Linux on ARMv8 using Open Embedded as a basis. Marcin at the front here did a lot of the work to start off with. And you can run X on it, so you can actually get some graphical display working. So it's not beyond the realms of actually getting your hands dirty on it now if you wanted to. It's all there.
Yeah, you say that you can run X11, but to get graphic output, you need to have a license from ARM.
True. So get your checkbooks out and send us a check, and we'll enable you to get graphics working fully. But the foundation model that we provide will allow you to run it on your desktop, your laptop, and you can actually have a look, see how things work. That's a lot of the work that OpenSUSE are doing, and also that Fedora are doing using the foundation model. I'm not 100% sure on Debian and whether they're using the foundation model or if they are. Yeah. So yeah, it's the best tool there that's being used by the majority of people that are actually going forward.
Are there any distributions available for AR64 yet?
It depends on how you class a distribution. I would say the best one would be Open Embedded to start off with. The initial founding work was done using Open Embedded, but Fedora are getting there.
Sorry.
Yes, there's no RTOS available yet, but yeah, it's getting there. So the more that join in on either the distribution side or within the general community, the quicker we can get things rolling. Obviously, hardware would be nice to have now, so you can actually test what you're doing. But it's coming. So hopefully within 18 months, you'll definitely see some real-world hardware available. There'll be numerous companies that have committed to it, so it is just a matter of time. So anybody got any questions at all? Anybody got questions on some of the lower level stuff with regards to the compiler? The triplet has been agreed across the distributions, hopefully. Everyone's accepted what has been discussed. So it's my understanding from speaking to some of the Debian community is that with them using multi-arch, they will be more than likely calling it ARM64. Both Fedora and OpenSUSE will be calling it ARch64. And any 32-bit binaries that Debian have will be ARM32. My understanding is Fedora won't be doing any 32-bit. Is that correct on the ARch64? Right. So, and I believe OpenSUSE are also not planning on providing any 32-bit.
Yeah, sorry, we did. I didn't want to do this. I wanted to move everything to /lib. We did switch to lib64, just in case.
Yeah, that's the same for OpenSUSE. I believe they're going to use lib64, and RPM will support both ELF32 and ELF64 in case there is a requirement, but the intention is 64-bit.
John, correct me if I'm wrong, can you run 32-bit user space in chert root on ARM64? Or is that's the plan, we'll be able to do it if people want that?
No. Well, maybe. The thing is, we're going to go to 64K page size probably as well. So you'll be able to do some stuff might work in the chroot, but I've been trying to break that as much as possible, and I haven't succeeded yet. So you know, I think virtualization is the way to do 32-bit. I don't think you should run 32-bit code.
Right.
But others disagree. And
I mean,
it might work, but I think honestly, if you go into 64K pages as well, too many random things are going to start breaking. That I don't think it's a good idea.
Sure, I mean, one of the uses of ARch64 is that you can have a 64-bit kernel and your user space is 32-bit only. That's been designed like that out of the box. So you have the option there to run either architecture. Any other questions? Any comments? Questions?
They won't hear you the other end of the wires on the internet.
Are there any chances of doing fat binaries with ELF? Is it under research by anyone doing the distros or?
Yeah, it probably is more of a pattern issue, really, more than I'm not aware of anybody having looked at that.
Sorry, I don't want to hog things. Someone did do a fat binary thing on LKML a few years back, but it was, I think, a patent issue more than anything else.
Yeah, it's. I've not heard of anybody looking at it. It's not saying nobody's done it or it can't be done, but actually having it out in public could potentially be an issue.
I'll lose weight at this rate.
So there, as John says, there is a way of doing it with ELF. It's
Yeah,
not ruled out.
it is
completely.
possible. It's the legality implications are there. So it could potentially be done in-house and kept in-house as long as it never comes out, maybe. But as far as I'm aware, nobody's really looked at it. So, yeah. So if, the comment was if you're using multi-arch like Debian and Ubuntu are, then why do you need FAT library? You don't really. It's more if you're not. John, shush. One of the other items to mention is with regards to graphics, apart from no open source driver available for the new Mali graphics side of things, the new 600 series of Mali graphics driver was designed with supporting ARMv8. So there will be 3D accelerated graphics available once there are ARMv8 devices out there. Whether they make it into consumer devices as laptops, whether Google provide a 64-bit Chromebook, I have no idea, but it's possible for them to do that with the foundation work that was done. It was all intentional. When the new 600 series was designed, there was a lot of the founding work for ARMv8 going alongside, so they were able to synergize somewhat to make sure there was full support when products ship. Any other questions?
I have a question more to the audience. How many of you ever booted ARMv8 in model? Except guys working on it.
So please, download the foundation model. You need to provide an email address. That's it. And then you can boot up and actually have a look at it. I'm not saying you're going to see bells and whistles, but you can actually get a feel and an idea of what's there, how things work. You can even start trying to package or run your application if you're a software developer and see how that works.
I have a question. Can we still download reference models for ARMv7 and therefore allow us to do an attempt at performance comparison?
I don't think.
That one's easy to answer. The simple answer there is emulators don't get you any performance hints, period. Because, I mean, if you, for example, if your host can run 32-bit instructions really easy and fast, and you're emulating 64-bit instruction set that it will take longer time on that host, that wouldn't give you any hint at all on how fast the system that you're emulating would eventually be in hardware.
Also, you wouldn't, if you did do any performance comparison, you wouldn't be allowed to publish them. But that's by the by. I'm not a legal expert, but I do know that the EULA does kind of say no. Um, but you can get an idea for how things work rather than getting a real world comparison of how it really is going to work. For that, you really need hardware. And then hopefully when real ARMv8 hardware is out, you can do a real world comparison, because hopefully they're all working in synergy, unlike ARMv7, where there are certain aspects that are implemented differently by one vendor to another.
I would like also add one thing. If someone is trying to work on porting some distro or something to ARMv8, please use eglibc 2.17. Nothing older is expected to work properly. It was already noticed with open embedded builds. We forced to 17 to our layer of recipes. And with 2.16, you can have things like you are using Vega to fetch file, and it will tell, oh, I already fetched 7 terabytes of data in 1 second, and it will just fail or hang or something else, but it will for sure not work properly.
Any other questions, comments, wishes, desires?
Is there any plans for ARM to open source any of the Mali stuff like Intel and others have done with their GPU drivers?
At the moment, there's no plans that I'm aware of. There are regular discussions about open source drivers, but it's laden with issues. It took Intel a long time to release an open source driver that genuinely worked how one would expect. So we're not under any misconception that, oh, it's easy, we'll just open source it and everything will be perfect. It's much more complex than that. So there's a whole raft of levels that it needs to go through before we can do something like that.
Did you note the QEMU work that's happening?
No, I didn't. Good point.
Because we've got this group in Linaro now called Linaro Enterprise Group, and one of the things we're trying to do is coordinate some of these efforts. And it's the work we're doing is public. I mean, the minutes are out there. You can track what we're up to. And one of the tasks at some point is going to be QEMU support. Although exactly how and when that lands is still being figured out. But there will be a QEMU model eventually.
Yes.
So right. Well, it doesn't have to be a system model. There has to be an I/O model. It has to be a user's right. But there's a full system model planned as well. So.
Anybody working on it yet?
Yeah.
So, things are moving forward, so it should all hopefully work out of the box. But without involvement from the community and feedback from the community, it won't necessarily happen as quickly as you may hope. The last thing we want to do is push out an architecture that causes more headaches than you need. We want ARMv8 to be adopted. We want the community to be able to run on V8, and we can help, and we'll see what we can do.
One comment here, if you have any kind of plans to port your distribution to ARMv8, we have a project at Linaro for tracking all the patches and bugs people have with software running on ARMv8. The address is launchpad.net/linaro-arc64. So you might want to subscribe to this bug tracker if you are going to port your distribution to ARMv8.
Thanks, Riku. Anything else? Going once, twice? Oh, in that case, thanks very much, and hope you have fun.